So guys, welcome back to my YouTube channel. Today we are going to see the solution part of this particular problem, that is minimum number of arrays to burst a balloon. We have already seen the description part of this problem where we have understood that what the problem statement was trying to tell us. Now we will quickly deal with the solution of this problem. The balloons are represented as a 2D integer array points where points at I consists of x start x end denotes the balloon's horizontal diameter. So each of these balloons are represented in this form. Suppose the first balloon is there, so its starting coordinate is 10 and the ending coordinate is 16. Second balloon is this one, starting and ending coordinates 2 and 8. Similarly, this this thing goes on. Okay, now, since it is not in a sorted format, in order to solve this problem efficiently, we first need to sort it. Sort this 2D array. Sort this 2D array. And what we are going to take is, we are going to take the ending coordinates of these balloons as the parameter for sorting our these what we call it, these horizontal diameters, basically the ending vertex. So what it will look like is, it will become 1 comma 6 followed by 2 comma 8 followed by 7 comma 12 followed by 10 comma 16. Okay, on the basis of the increasing order of these elements we have sorted this thing. Now we know that if there is a intersection of more than one balloons, suppose there are three in this example, that in this diagram that I have taken, so single arrow is enough in order to burst all these three elements. So what we are going to do is, we create a variable that will mark the ending vertex of the first balloon. Okay, and we will run a for loop, and what we are going to do is, we are going to check that whether the starting coordinates of the upcoming balloons, basically the upcoming balloons diameter, basically, is less than or is greater than the ending coordinates of the previous balloon, that is the first balloon. Then what we are going to do is, it will tell us that there is no intersection. Since suppose here in this case, uh, we can tell that. Okay, so here 1 comma 6 is there and 2 comma 8 is there. So 1 comma 6, suppose this is now, and 1 comma 6, this balloon will look like this. Okay, okay, 1 comma 6, and there's another balloon in 2 comma 8, so it will somewhat look like this 2 comma 8. So since the starting point of the upcoming balloon is less than the ending point of the previous balloon, then it will definitely tell us that there is an intersection of these two balloons. So with a single arrow we can burst these two balloons. So we will initialize an variable, that is arrow to 1. Okay, so since it is smaller than the ending point of the previous balloon, so we are not going to do anything. So the first time we encounter a starting coordinate greater than the ending coordinate of the first balloon, what we are going to do is, we are going to increment our arrow pointer, and the first thing that we know, the variable that we have created in order to store this end point of the first element, we will shift it to the end point of this thing, that is 7 that will store the 12, basically. Okay, and it will increment the pointer. So again we will check that now 10, the starting variable, the starting coordinate is less than the the ending coordinate of the previous one, so we are not going to do anything and simply return the array. So it is 2 in this particular case. Okay, so answer is also 2. So what it tells basically. So suppose 7 to 12 was, okay, let me clear this thing na? Okay, so what was the two things that we know that were there? One was 7 comma 12 and another was 10 comma 16. Okay, so suppose 7 comma 12 is there. Okay, 7 comma 12 is there, followed by 10 comma 16, by 10 comma 16, followed by 10 comma 16. So there is, one intersection is there. Okay, so only single arrow will be required. Single arrow will be required for this case, and single arrow will be required for these two cases, these two balloons basically. So the answer will be 2. Okay, so I hope that I have explained this problem pretty well. Now we are trying to code this particular problem on lead code basically.